You jog 3 kilometers north, an unknown distance and direction, and then 2 kilometers at 25 degrees south of west, and end up at 5 kilometers at 25 degrees north of east. Determine the unknown vector that you traveled. Oh, determine the unknown vector. It doesn't say unknown magnitude of the vector, it just says unknown vector. So we might have to look for not only the magnitude of the final vector, or of the unknown, so it's going to be 1, 2. The second one, not only the magnitude, but we're probably going to also look for the angle of the vector, because it's saying the unknown vector, the whole thing. Okay, so let's draw up the thing here. Where am I going? North, then south of west. Well, that's this way. End up at north of east. North of east. East is this way, north of east. Okay, so I'm just going to draw the top half of the coordinate system here. There it is. So there's my y, there's my x. So my first leg is 3 kilometers north. There it is. An unknown distance. Oh. And a direction. And then 2 kilometers at 25 south of west. Okay, and then I end up at 5 kilometers north of east. Let's do the ending one. So I end up at 5 kilometers north of east. Which way is east? East is this way. North of east is this way. So I end up like here, 5 kilometers, like way over here. Okay, so there's my final. We know this angle is 25 degrees north of east. And we know that the one that came from here was 2 kilometers at 25 south of west. South of west is this way, and south of west is this way, 25 degrees. Oh, so it's pretty much like this, because that's west right there, and then south of west was 25 degrees. Okay, so that's our third leg, and then our second leg was unknown. Now, the reason why I'm doing this is it's very complicated to actually figure out this one. So it doesn't really matter if I do leg 1, here's leg 1. Leg 2 is an unknown distance and direction. And then leg 3. It doesn't really matter just because they're being added together anyways. It doesn't matter if I call this one 1, and I'll call this one 2, and then I'll call this one 3. It'll make my drawing a little easier to understand it. And if you had something like this, you wouldn't have to try to figure out in the middle. So I'm just going to call this V1 vector. I'll call this one V2 vector, because then I traveled here of my 2, and this is going to be 25 degrees here. 25 degrees. And then my unknown distance. So I'm not going to do this one. Because they're added together, it doesn't matter really what order you add them. Okay, so like we talked about, I'll call this one 1, I'll call this one leg 2, and then my leg 3 will be my unknown distance. That will be V3. And this will be V2. And this is V final. Okay, so let's do some trig here. Well, we have to first let's do this guy right here. So we have this guy here. We know that this angle here is 25 degrees. And there's this one. We'll call that Y. We'll call this X. And this distance was, well, this is number 2, which is this one. So 2 kilometers. Okay, so X is going to be equal to 2 cosine of 25. And Y is equal to 2 sine 25. Okay, we have one more. We have the final vector, so this is going to be at 25 up. A lot of 25s here. So 25 up, and the distance was 5 kilometers. Okay, and we'll call this X, we'll call this Y. So then X is equal to 5 times cosine of 25, and Y is equal to 5 times sine of 25. And now we can do some math. So 2 cosine 25 is 1.813 3. I can also change that to a 5 cosine 25, and I have this one is going to be 4.532. And then I can change that to a sine, 5 sine 25, 5 sine 25, which gives me 2.113. And then I can change that to a 2 sine 25 will leave me with a 0.845. Okay, so I got all my components. What's the vector that we're looking for here? v1 vector plus v2 vector plus v3 vector equals v final vector. Okay, see, it doesn't matter if you interchange 2 and 3 because you're adding them together. So we're trying to solve for v3 here. So v3, we're going to subtract v1 and v2 from both sides. So we're left with v3 vector is equal to v final vector minus v1 vector minus v2 vector. Okay, there's our equation that we're going to solve. And let's do it. So v final vector is equal to v negative v1 vector is equal to, and negative v2 vector is equal to. We add up all those things together, we're going to get v3 vector. So v final vector is the red one. X direction is going to be positive. So it's going to be 4.532 x hat. The y direction is also positive. It went upwards. So it's going to be plus 2.113 y hat. Remember, these numbers always come out positive because I'm using an angle between 0 and 90 degrees, so I manually have to put in those negatives. v1 vector was just in the y direction, so 0 in the x hat direction, but it was positive in the y direction because it was going north, so it's actually going to be negative, so minus 3 y hat. Now, v2 vector, this always gets a little complicated. v2 vector is going to be negative x direction, but because I'm taking negative v2 vector, it's actually going to be positive. So this is going to be 1.813 x hat, and then it's going to be negative in the y direction, but then the minus of that will make it positive, so it'll be plus, minus, that's right, both minus x and both minus y, so they'll be both plus 0.845 y hat. So 4.532 plus 1.813 is 6.345 x hat, and 2.113 minus 3 plus 0.845 is negative 0.042, almost nothing. Okay, great. So there's our vector. It said determine the unknown vector that you traveled. Oh, I guess that could be the answer, actually. There is the unknown vector. Just to make sure I've done everything, let's determine the magnitude and the angle as well. Okay, so the magnitude of this vector is going to be the square root of that one plus the square root of that one, and squared plus squared square root of everything. So 6.345 squared plus 0.042 squared. Whoa, 6.345 squared plus 0.042 squared equals square root answer equals is going to be 6.345 kilometers. That's a little too much. I would make it 6.3 kilometers. Okay, that's a better answer. Question was given to me in 1 or 2 sig figs, so I can give it back in 2. Now, the angle here, the angle is always hard to classify which angle you're talking about. So I always like to draw a little picture to say this is the angle I'm talking about. So here it is. It was actually going up here. Oh, no, it is minus y. So there it is right there. There is my final vector, v3 vector. And this is the angle that I'm talking about. Okay, so that angle for v3 vector will be equal to the inverse tangent of the opposite over hypotenuse. And I'm not going to use negative. If I use negative here, I'll get a negative angle, and I guess that makes sense. But because I've given the drawing, I think everyone knows what angle I'm going to talk about. I'm going to talk about a positive angle. So I'm going to take tan inverse of opposite over or opposite over adjacent. Sorry, if I use sine or cosine, it would be over hypotenuse. Because I'm using tan, it's going to be opposite over adjacent. I know both these values. I know the y value was 0.042, and I'm not using negative. I told you why I'm not using negative, because if I use negative, I'm going to get a negative answer. And I think I've been clear enough to say, here's the angle I'm talking about. And 6.345, that's over hypotenuse. So the angle here it's going to be tan inverse, bracket open, of 0.42 divided by 6.345. Yeah, that one had no contribution for the size. Look at this. It's pretty much the same distance as the x direction. That makes sense. Bracket closed. Equals. Is going to be, and am I in degrees? I am in degrees. Look how small that angle is. It's 0.4 degrees, which is just nothing. Things pretty much going horizontally.